Now, if you look at this question, find out that this question is from percentage yield. Okay, it's on percentage yield. Now, what is percentage yield? Percentage yield is just the measure of the efficiency of a reaction. Okay, yes, the measure of the efficiency of a reaction. Percentage yield is actually is the measure of the efficiency of a reaction. Now, percentage yield normally, the percentage yield is usually equals to the actual yield. Okay, actual yield divided by the theoretical theoretical yield. Okay, theoretical yield times 100. Okay, yes. Now, percentage has to do with the efficiency of a reaction. Okay, yes. Now, what is actual yield and what is theoretical yield? Now, actual yield is that mass um, of product that usually form when you carry out the reaction. Okay, that is the actual yield. Okay, then theoretical yield is that mass of product you usually got from calculation. Okay, yeah. So this is the actual yield, this is the theoretical yield. Okay, so when you carry out the reaction, for example, that mass, let's say for example, you reacted hydrogen with oxygen to form water. Now you carry out now you let's say okay, let's say theoretically, from calculation, you said okay, if you carry out this reaction, you produce 100 grams of hydrogen. That is, you calculated it. You calculated it and you got, that is when you do the calculation, you got the gram of water that will be formed is 100 grams. That is the theoretical yield. Now, when you now carry out the actual reaction, you find out that maybe the mass of water then produced, let's say, is now 98 grams. So this mass of water that is being produced by when you carry out the reaction, this mass is known as the actual yield. Okay, this is known as the actual yield. But theoretical yield is what you calculate. Okay, yes. So now, so if you look at this question, they said we should look for the theoretical yield, then we should look at the percentage yield. If you look at now, you find out that, look at it. They say the explosive TNT is made from toluene and HNO3. The equation for the reaction is this. Is the equation for the reaction. Okay, when 100 grams of toluene and 150 grams of HNO3 are mixed together, 1 to 2.5 grams of toluene of TNT is obtained. I understand. So that is when they carry out the actual reaction, when they do the reaction, the yield, then when they do the reaction, the mass of TNT formed is 2.5, right? I mean 1 to 2.5, 1 to 2.5. So this mass is known as the actual yield. Okay, now they say you calculate for a theoretical yield. Then we have to calculate for the theoretical yield. Let's do the calculation. Now let's calculate. As I said, toluene and HNO3 reacted to form TNT. So we want to get the so you calculate the mass of TNT. Remember, actual yield is the mass of the product you get when you when you do the reaction in practical. Then theoretical yield is that yield that you get from calculation. Okay, so they're asking us to get what the theoretical yield. We want to get the theoretical yield from calculation. Okay, now let's go back to the question again. If you look at the question, I said the explosive TNT, which is this guy here, is made from toluene, this toluene, and HNO3. The equation of the reaction, this is the equation of the reaction. Now they say when 100 grams of toluene, 100 grams of this guy, and 150 grams of HNO3 mixed together, 1 to 2.5 grams of TNT is obtained. Now, if you look at this question, what comes to your mind? What comes to your mind is limiting reagents. Remember, because if you look at it, we are relating two reactants to what? To one product. I don't understand. We want to look at the theoretical yield first, right? We want to look at the mass of TNT. The mass of TNT. We want to look for it that is being produced when 100 grams of toluene and 150 grams of HNO3 react. Okay, yes, but remember, so guys, we usually relate one reactant to one product, not two reactants to one product. So what are we going to do? We want to look for the limiting reagent. So I want to be fast. Okay, how are we going to look for limiting reagent? I've shown you guys earlier. Okay, so let's be fast. Okay, now Now this is the mass of toluene. What is the mass of toluene? We need to convert it to mole, right? We need to convert 100 gram to mole. Let's do it. So 100 divided by the molar mass of toluene. Okay, the molar mass of toluene. Let's calculate the molar mass of toluene. The mass of carbon is 6. I mean it's 12. 12 times 7. That is for 84. Then plus mass of hydrogen is 1. 1 times 8 is 8. So 8 plus, okay, we get 92. So the molar mass of toluene is 92, right? Yes. Then what about HNO3? Want to convert this mass to mole, right? 150 divided HNO3. Let's get the molar mass of HNO3. So hydrogen is 1, then plus nitrogen is 1, which is 14. Uh, okay, oxygen is 16. 16 times 3. 16 times 3 will give us 48. Then plus mass number of nitrogen is 14. Then mass number of just one nitrogen here is 1. Okay, so the mass number of the molar mass of HNO3 is 63. Okay, remember how do we get the unity reagent earlier? With the mass of the reactant, we got the mole first. When we get the mole, we then divide each of the mole by the coefficient of the reactant. Okay, so what is the mole of this one? 100. 100 going to divide 92, right? Is 1 point coming. So the mole of this guy is oh god, what am I done? Okay, let me do it again. All right. Okay, the mole of this guy is 1.086. If we divide this one, we get, what will we get? 150 divide 63. 150 divide 63. When we did, we get 2.8 381. 381. Now this is the mole of this one. This is the mole of toluene. This is the mole of HNO3, right? Now what are we going to do next? Remember I told you guys we will divide the mole by what? The coefficient. What is the coefficient of toluene? It's just 1, right? Yes. What is the coefficient of HNO3? Is 3, right? This one divide 1 will still give us 1.086. This one divide 3. Okay, I'm coming. 2.381 divide 3. We get 0.7936. If you compare, which one is bigger? This is bigger, this is smaller. So therefore, HNO3 is limiting reagent. So we have to relate what? We have to relate HNO3 with what? With TNT. Okay. Yes. Now, according to what are we looking for? Remember, we want to look for theoretical heat, right? That is the mass. The way you calculate what the theoretical heat, that is the mass of the product we usually get from calculation. While actual heat is the one we get when we do the actual reaction. Okay. Theoretical heat is one we get from calculation, just like what we are doing now. I want to get the mass of TNT. Yes, that is using calculation now. So we are relating these two guys. So according to normal mole to mole relationship, how many moles of 3 mole of HNO3 give how many mole of TNT? Just 1 mole, right? Yes. Now let's go to the question. They say 150 gram of HNO3. Remember, when using mole to mole relationship, we need to convert this 150 gram to mole, right? Yes. So let's do it. 150 gram. Okay. How are we going to do it? Convert it to mole by the what? Giving mass rather than molar mass, right? What is giving mass of? Okay, sorry. Now what is giving mass of HNO3 is 150. Molar mass of HNO3, let's calculate it again, okay? Oxygen is 16 times 3, that's 48, then plus one, nitrogen is 14, hydrogen is 1, so 63. So 150 going to 63. Now let's divide. 150 divide 63, 150 divide 63. When we divide, the mole of HNO3, the mole of HNO3 is 2.381, right? Yes. So therefore we say if 3 mole, okay, 2.381. Okay. Now if 3 mole of HNO3 produce 1 mole of TNT, then 2.381 mole of HNO3 will produce an S mole of TNT. Now remember, like what we are doing earlier, since once we do this relationship, we want to get the mole of TNT first. Once we get the mole of TNT, we convert that mole to mass. So cross multiply 3 times s give us 3s, 1 times 2.381 to give us 2.381. That goes out by 3. Okay, so and divide by 3. Okay, I'm coming. This one 3 will cancel 3, we left. This one will cancel 3, we left. Let's equals to what? 2.381 divided by 3. We have what? We have 0.793. Let me open 0.794. Okay, so this is the mole of TNT form. Okay, yes. Are we done yet? No. We have gotten a mole. Now, what I'm going to do next? Convert the mole to mass. So remember, number of moles is equals to what? Giving mass over our molar mass, right? Yes. Now, what is the mole of? Okay, we got the mole. The mole is 0.794, right? The given mass which we are looking for, molar mass. Now, what is the molar mass of TNT? Let's calculate it from here. Okay, so let's just do it. Okay, so mass of carbon is 12. 12 times 7. That is 84. Okay, 84. 84. Okay, then plus hydrogen is 1. 1 times 5. 5. Then plus nitrogen. These three are nitrogen. So nitrogen is 14. 14 times 3. 14 times 3 is 42. Plus 42. Then oxygen is 16. And 3 times 2 give us 6. So 6 times 16 give us 96. 96. So now let's add everything. 96 plus 42 plus 5 plus 84. So we do everything, get 227. So the molar mass of TNT is 227. 227, we cross multiply. 227 times 0.794. So when we do it, we get 180. 180.238. So the theoretical yield is 180.238. Remember, what is theoretical yield? That mass of the product we get from calculation. That's which calculate for theoretical yield, which is the mass of the product form. Yes. Okay, remember, percentage is equal to actual yield over theoretical yield and times 100. So actual yield, they said the actual yield when they do the reaction, 1 to 2.5 gram of TNT was formed. This is the actual yield. Now actual yield is one with the mass of the product we get when we carry out the practical the reaction we carry it physically, carry out the reaction. Now what theoretical is one we get when we calculate the mass of the product we calculate, we get from calculation. Okay, yes. So it's 180.238. Okay, now what the solution for percentage yield, right? So remember, percentage yield equals to what? Actual yield divided by theoretical yield, right? Actual yield is what? The one they get from the reaction, from when they do the reaction, 1 to 2.5 gram, right? Now the theoretical yield one we get when we do the calculation is 180.238. So if we times 100, so if we do everything, remember actual yield divided by theoretical yield then times what? 100. So we do everything. Let's do everything, okay? 1 to 2.5 times 100 divided by 180.238. So when you do everything, get 67.9. So therefore, the percentage is 67.9%. So that is just it. So this is how you can solve percentage yield. Okay, it's very easy. Know the actual, the theoretical yield. Divide them times 100. Please, no question that's coming out from you will know that you just know question that's coming out from limited reagents or limited reactant. You can just know, okay, it's very easy. I've shown you guys. Now let's move to the last part of this class. Stoichiometry of solution, where we're talking about molarity, molality, and normality. Okay.